12.3 follows up with the idea of probability, but taking us into permutations and combinations. Something you probably talked about in middle school and or Algebra 1. Maybe not. Okay, but being able to look at something and see how many different combinations or orderings there are, how many different groupings there are, that type of thing there. So, okay, so I'm going to get us into it, okay, into the right thinking here. Holly, Tia, Kenji, and Nate are eligible to be officers of the Honor Society. 2 of the 4 students will be chosen at random as president and vice president. The table summarizes the possible outcomes. So you've got your various outcomes here for president and vice president of these 4 students. Okay, and again, it says it's chosen at random. A. Holly wants to be an officer with her best friend Tia. How many outcomes make up this event? 2. What 2 do we see here? Okay, we've got a Holly and Tia, a Tia and Holly, and it's basically where one of them's president, one of them's vice president, right? So there are 2. Holly, Tia, Tia, Holly, and you can see from the grouping that where Holly is vice president and Tia is president and vice versa. How many outcomes show Holly as president and Tia as vice president?
1.
Someone finished my Kleenex and didn't tell me. Okay, that was what? 1? Okay, so when we get, and the difference there is order is specific, right? Okay, so we're kind of looking at the difference here. Just either way. President, vice president, president. Order doesn't matter in this first one. This one, order matters because Holly is president and Tia as vice president is just going to happen. Not that one, the other one, huh? Which one? Yeah, this one. Holly is president, Tia is vice president. So that only happens at HT. Okay. How many outcomes have only one of them as an officer? Explain. Or demonstrate, one or the other. So how many outcomes have only one of them being Holly and Tia, as an officer? Start listing them for me.
HK, HN, TK, TN, KH, KT, NH, NT.
Okay. So do you see the 8? 8 of them with only one of them, so either 8 that have either just Holly or just Tia, combined with then either Kenji or Nate. Okay. So there are 8 there. My explanation is just going to be listing them real quick. So HK, HN, TK, TN, KH, KT, NH, NT. Okay? So, again, looking at these groupings, does order matter, doesn't matter, and that's going to be a big part of our discussion as we go through and talk about permutations and combinations. Well, a chart is not necessary, it is helpful at times, isn't it? Okay, so, okay. This leads us into talking about the fundamental principle of counting. Okay, so let's look at this example. You've done stuff like this before back in middle school. Whether you remember it, I know is a different story. Manuel wants to advertise the number of one-topping pizzas he offers to his customers. How many different one-topping pizzas are available at Manuel's Pizzeria? Thoughts?
That's where you list it out.
Okay.
I'm gonna do the tree thing.
You can't.
1, 2, 3.
I have a tree thing on mine. Okay. Tree diagram. You can list them out. Are we leading into the shortcut of you can just multiply? I'm going to say we're leading into that one.
I wish I had done that in middle school.
What, multiplying?
Yeah.
You did. It was taught in there.
I doubt.
But here's the question. This one is how many different one-topping pizzas? Is it asking that are we required to list them? No. So could we just jump right into multiplying? We can't. Now, I'm going to review the tree diagram just because it's a helpful tool at times. I know you guys are like, whatever, but it is helpful to remember at times. So if we think tree diagram, think about choices. What's the first choice you make on your pizza? If we just go in order here.
Small, medium, large, or larger, medium.
This pizza is special. It only has large or medium. No smalls.
No personal pieces.
I guess not. Okay, so I'm going to set it up. And you can set up going across. I have mine set up going down. But the idea that your first pick is either large or medium. Agreed? Or that is a pick. How's that? And that is our size. Okay, after you pick your pizza size, what are you doing?
Choose the crust.
Okay, you're going to choose a crust. What are my options here? Deep dish or thin. So if I chose a large pizza, I could choose what? Deep dish or thin. I'm going to use DD and TH. However, if I chose a medium pizza, what could I pick? Deep dish or thin. So that is my crust. After you pick crust, what are you picking? Now we're finally to the topping. Now, what is the specific in this situation? We're choosing what kind of pizza? A single topping, one topping pizza, right? So the next thing we're going to look at is toppings. So options here. If I picked a large deep dish pizza, I could now pick sausage, pepperoni, or cheese. So I'm going to set this up as sausage, pepperoni, or cheese. You don't have to write the words out, whatever you need to do to abbreviate. If I picked a large thin crust pizza, what topping could I pick? Sausage, pepperoni, or cheese. If I picked a medium deep dish, I could pick sausage, pepperoni, or cheese. If I picked a medium thin crust, I could pick sausage, pepperoni, or cheese.
So if you choose sausage or pepperoni, there's no cheese on your pizza. It's just sauce.
No, one topping pizza automatic. A one topping pizza would be an automatic cheese pizza with a topping.
So what happens if you get cheese though?
It's just cheese.
Extra cheese?
I don't know.
Nope, because you can only have one topping. No extras.
I got nothing on that one. I will say cheese is usually considered a one topping pizza, just as sausage and pepperoni are considered one topping pizzas. So that's how it works in the pizza business. Rip off or not, I don't know. Okay, now, just looking at our tree diagram. The question was, how many different one topping pizzas are available? How do we figure out how many different one topping pizzas are available here? 12 because count your last row, which shows that there are 12. Because I just listed all the pizzas as I was doing it, right? I could have a large deep dish sausage, large deep dish pepperoni, large deep dish cheese. There's 3 pizzas, yes? And we do that 3 more times. Now, leading into the multiplying. The idea is if we had multiplied, okay, how many size choices do you have? You have 2. Times how many crust choices do you have? 2. Times how many topping choices do you have? 3? Well, 2 times 2 times 3 is 12. Okay? So no, nothing says we had to do a tree diagram here. We could have jumped right into multiplying. I also know it's probably been at least 2 years since you've done this topic. That is, if you did it in Algebra 1. If you didn't do it in Algebra 1, it's been longer because it's been back to middle school. So. Huh?
Yeah.
Okay. Fundamental accounting principle. This is the official way to say what we just did. If there are m ways to make the first selection and n ways to make the second selection, there are m times n ways to make the 2 selections. Or if what we just did, if there's a third selection with p choices added, then there are m times n times p ways to make all 3 selections, and so on. Okay, so however many choices you have to make, multiplying those selections. That is what we call the fundamental accounting principle. Okay, you've probably used it. Whether you knew what it was called is a whole different story. So let's look at this one. The car that Ms. Garcia is buying comes with a choice of 3 trim lines, standard, sport, or luxury, 2 types of transmission, automatic or manual, and 8 colors. How many different option packages does Ms. Garcia have to choose from? What do you know?
3 trim lines.
Okay. Her first choice, or A choice, is trim lines. And we know that there are 3. Then she has to pick a transmission. How many transmission choices? 2. And then she's got to pick a color. How many color choices does she have? 8. What are we going to do? We're going to multiply. We're taking her choices and we're multiplying. Because she doesn't get more than 1 trim line. She doesn't get more than 1 transmission. She doesn't get more than 1 color. Those aren't the options here. So 3 times 2 times 8 is 48. So to pick her option package on this vehicle, she has 48 options. And I feel like we didn't even touch some of the options that she would have to pick. But
Does your format?
exactly. Okay, fundamental accounting principle. Could we have done a tree diagram with this 48? Technically, yes. Would have been messy. Oh, yeah.
Except we have another 8 colors.
We could have made up 8 colors. Okay, so that leads us into permutations. Okay, officially the gist of this lesson is permutations, combinations. Okay, now permutations. A permutation is an arrangement of objects in a specific order. Okay, so key phrase here. In a specific order. Okay, you want to remember a permutation, order matters. Okay. Now, the number of permutations of R objects taken from a set of N objects, and we have a formula here. I'm going to show you a couple of different ways you can do this. I should have had you pick up calculators because this is something that I will eventually talk about. We can also do on the calculator. However, you are going to be required to be able to set it up on quiz and test. Okay, so while you can use the calculator to an extent, you do still also have to know the setup behind it. Okay, that is to get full credit at least. Now, so what we have here, in objects chosen R at a time, is in with an exclamation point over it, or behind it, over N minus R, exclamation point. Do you guys remember the exclamation point in math?
Nope.
Because it's not an exclamation point. Okay, it's not an exclamation point. That's what it is in Miss Minnick's room or Miss Higgins' room. But in my room, it's a factorial. Okay, so the factorial of a positive integer is the product of all positive integers less than or equal to n. It is written as n factorial, or n exclamation point, and is read as n factorial. Now, and this is just kind of a side note, by definition, 0 factorial equals 1. So, I don't have an example written in my notes. Well, we're going to do an example. So, for example, we're going to do 5 factorial. Okay? If you see on your paper 5 exclamation point, that's not just 5, exactly. It has a math meaning. And notice it says it is the product of all positive integers less than or equal to n. So 5 times what's the next number? 4 times 3 times 2 times 1. Okay? 5 times 4 times 3 times 2 times 1 is 120. Okay? If we said 4 factorial, you'd strike off the 5 and it'd just be 4 times 3 times 2 times 1, so on and so forth. This is also something our calculators can do. Okay, again, I'm going to expect you to be able to write out that 5 factorial is 5, 4, 3, 2, 1, but this is also something our calculators can do for us, and I will show that when the time is right. Okay? So, with that in mind, let's talk about some permutations, okay? So right here, I mean, if I'm up front with you, these are permutations. Order does matter in what we're going through. So eventually we'll hit a point where you're going to have to pick. Is it a permutation where order matters, or guess the other one is combination where order does not matter? So for right now, we're just trying to figure out how to do a permutation. So Gabriella is making a playlist with her 3 favorite songs. How many possible orders are there for the songs? Now, there's a couple different ways we can do this. Making a playlist with her 3 favorite songs. Does order matter here? I mean, I've already told you it does because it's on this page, but when you're making a playlist, what song plays first versus second versus third? Okay? Order matters. When you have something and you're trying to put, this is a list of, with her 3 favorite songs, we're trying to order 3 different things. It's 3 things to fill 3 spots. And so order is always going to matter in that situation. Now, options of how to do this one. Could we make a list? We could. Okay. I think in my notes, and again, I'm showing ideas here. In my notes, I called these songs A, B, and C. Okay. What's an order we could go with? She could use A, B, C. What else? Okay. I heard BCA. I heard ACB. CBA.
BAC.
BAC.
CAB.
CAB. Okay. Now, this is only for ordering 3 things. I don't know, did you instantly come up with all 6 of those, or would you have missed some if you didn't have your classmates helping you? Okay, and this is why we have ways to do this otherwise. Now, I'm not even going to use the permutation formula on this one. I'm going to keep it more basic. How many things are we trying to order? 3. So, how many blanks am I filling? 3. How many choices does Gabriella have for her first song? She has all 3 choices, or all 3 songs. How many choices does Gabriella have for her second song? She had 3 choices for the first blank. What's she going to do in that first blank? She's going to pick one, yes? As we move on, now, how many choices for the next blank? 2, because she left one in the first blank, yes? Am I making sense here? How many choices for the third blank?
One.
1, because she already left him in the others. What do we do with the 3, 2, 1, do you think? Multiply. What is 3 times 2 times 1? 6. Does that go with the listing that we did? Okay, now, this was a small example, right? Am I going to make these lists every time? I'm rarely going to make these lists. That's why we have these other options, because making the list becomes next to impossible. Like this next one is very impossible. Okay? There's no way I'm making a list. Now Gabriella wants to make another playlist using 5 of the 8 songs from her favorite artist's latest album. How many playlists are possible? So this time, she's trying to pick how many songs? She's trying to pick 5 songs, so you could think about it as filling 5 blanks. But how many is she picking from? She's picking from 8 songs. Now, I'm going to set it up as blanks, but then I'm also going to show it with the permutation formula. Okay, so she's picking how many songs? 5. She's got to pick the first song, the second song, the third, the fourth, and the 5th. Yes? Okay, how many song choices for her first song pick? 8. So she's going to pick one of her 8 songs to put in that first spot. Now, how many choices for her second spot? 7. Because she picked a song for the first spot. So now she has one less song to pick from. So now she has 7. How many songs to pick from for her third spot? Are we following along here? She picks a song, leaves it in the third spot. How many for the fourth spot? 5. How many for the 5th spot? 4. What am I going to do with 8, 7, 6, 5, 4? We're going to multiply. Do you see why I didn't make the list this time? I don't have that kind of time. What is 8 times 7 times 6 times 5 times 4? Okay. 6,720. And by the way, if you did not grab a calculator today, you probably are going to want one at some point. Just saying. And now, that is perfectly fine what we just did there. Okay? Nothing wrong with that at all. I'm going to show an OR option here. Okay? We talked about the fact that order mattered, yes? Order mattered makes it a permutation. We were picking the permutation. We were picking from how many items? And that was picking from 8 items. How many spots were we trying to fill? 5 spots. So that makes this 8P5. Okay, that's your official permutation notation. Okay, where you can pick 8 things to fill 5, from 8 things to fill 5 spots. Now, look at the formula up above. This right here. NPR is equal to, on top, N factorial. Miss Minnick's pencil sharpener.
Really?
Yep. I don't usually hear it first hour, but yeah, that's her pencil sharpener that's over in that corner of her room.
Like a screwdriver or something.
Okay. On top, if it's N factorial, what am I going to put on top? 8 is in the N spot, right? So it's going to be 8 factorial on top. On bottom, N minus R factorial. So what are we going to have? 8 minus 5 factorial. On top then, we have 8 factorial. 8 minus 5 factorial. 3 factorial. Now, you technically can multiply this all out on the calculator. There's also shortcuts here. Okay? And I want to show real quick. I'm going to run out of room. But trying to pull this all together, okay? We talked up above. What does 8 factorial mean?
8 times 7 times 6.
Okay, starting at 8, multiplying all the way down, right? I'm writing this out for a reason because I want to show you a trick. On bottom, what does 3 factorial mean? 3 times 2 times 1. Yes? Now, what's the trick I'm pointing out? The numbers that are in common top and bottom can cancel. 3 cancels with 3, 2 cancels with 2, 1s can cancel or stay. What do I have on top? 8 times 7 times 6 times 5 times 4. Did we just multiply those numbers? That should have been the last thing you did on your calculator, right? 8 times 7 times 6 times 5 times 4. So, just to show it works both ways. Did we have to use a formula in this one? No. Are there times where you're going to want or need the formula? Yes. Because there's times when you're not going to be just doing 5 blanks, or you're not going to start with, a number as low as 8 or something. So, in a scenario like this, I'm okay with either or. I will tell you. Okay? There will be parts of the quiz test where I need to see the setup. Okay? Sometimes you may just have to tell me, is it a permutation or combination? But other times I'm going to test, can you do these setups? Okay? And so we'll talk about that more come review worksheet time. Okay? Okay, questions before I move forward? Are you looking at the next one? How many possibilities are there for Gabrielle's playlist if she uses her 4 favorite songs? What?
Why don't you just be 4 songs?
Uh-huh.
Just still 5 spots or 4 spots?
No. Just, so total new problem. This uses 4 favorite songs. So this is more like part A where she's just arranging her 4 favorite songs. So she picks her 4 favorite songs. It's a matter of how many orders are there she can arrange them in. What's an option of how I can do this? Could we do 4 times 3 times 2 times 1? Yeah. She's trying to take 4 things. So she's trying to fill and arrange them in 4 spots. So the first spot, the second spot, the third spot, the 4th spot. In the first spot, she can pick from how many song choices? 4. She puts a song in that first spot. How many choices for your second spot? 3. She puts a song in that spot. How many choices for the third spot? 2, and that takes us down to 1. 4 times 3 times 2 times 1 is 24. So she has 24 orders to pick from. Okay? Now, because I want to get us in the habit and ask, if we set this up as a permutation, how many things are we picking from? 4 songs. How many spots are we trying to put them in? 4 spots. So if I write this, I would be writing 4P4. Permutation of 4 things arranged 4 at a time. Okay? Now, on top, it's n factorial, which is the first one.
Oh, it's 0.
So 4 factorial. On bottom, it is n minus r, so 4 minus 4 factorial. Well, what is 4 minus 4? Now, so we have 4 factorial over 0 factorial. Okay, there was a definition earlier. And your calculator will agree with this. Okay, what is 0 factorial? By definition, it equals 1. It's not 0 times anything because that just doesn't make anything possible. So it's just 1. On top, 4 factorial is 4 times 3 times 2 times 1. Obviously, we're getting the same answer. Okay? I was never trying to set us up where we didn't get the same answer. Yes.
Remember to text or you're ready to write it out like the first one, or do we need to do
It'll depend on the problem. Okay. If it doesn't specifically ask you whether it's a permutation or combination, you'd probably be okay just to do this. Now, and I don't remember what I was putting on there, but if it specifically asks permutation or combination, then you're going to have to state that. And when you do that, you're probably just going to go this way, but yeah, it's going to depend. Okay. Okay, one last one in this section. How many possibilities are there for Gabriella's playlist if she uses 5 of the 10 most popular songs?
Equation.
Okay, this mimics question B. I agree. Okay, could you set up just blanks if you want to? And I guess I'm forgetting to say, does order matter here?
Yes.
Yeah, it's a playlist. Okay, we're already being told 5 songs, but then it's the playlist. So if I do blanks, how many blanks am I filling in? Not filling in 10 blanks. I'm picking 5 songs. So the first, the second, the third, the fourth, the fifth. How many choices for the first song? 10. How many choices for the second song? 9. She put 1 in the first blank. How many choices for the third song? 8. The fourth song? 7. The fifth song? 6. 10 times 9 times 8 times 7 times 6 is? 30,240. Definitely a reason I quit listing things. This is why we have our methods, right? Now, what is this the permutation of? We already talked order matter. It's a permutation of how many things arranged how many at a time. How many things? 10 arranged 5 at a time. And I will tell you guys, in a permutation or a combination, that first number has to be bigger or equal to the second number. The second number will always be the same or smaller, just so you know, okay? Now, on top, what goes on top? 10 factorial. What goes on bottom? 10 minus 5 factorial. What does 10 minus 5 factorial simplify to be? 5 factorial. And maybe if I have a moment, I'll demonstrate on the calculators and make sure we're finding this on the calculators. On top, what would 10 factorial mean? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. What does 5 factorial mean? 5, 4, 3, 2, 1. What are we finding here? Yeah, 5, 4, 3, 2, 1 are all on top and bottom. Do the numbers you have left match?
Yes.
Yeah. We have the 10, 9, 8, 7, 6 that we had on the first one, yes? What's this come out to be? The 30,240. Okay? I want to show calculators today or tomorrow.
Can you do it today?
Actually, I might wait. Here, let's look. Okay, we've got 6 minutes left. We're going to finish up our last example, right, gentlemen? In geometry, polygons are labeled by placing letters at their vertices. How many ways are there to label a triangle with the letters of the alphabet?
You get 26 letters in the alphabet. I agree.
Okay. How many blanks are we trying to fill? trying to fill 3 blanks because you have to label the first vertice, the second vertice, and the third vertice, right? First vertex, second vertex, third vertex. How many choices to label that first vertex? 26, because why? We know there's 26 letters of the alphabet. What about the second vertex? 25, because we labeled the first vertex, right? Do you reuse letters when you're labeling a polygon? No. So 25. How many left for the third? 24. Okay. What's the other option here?
26.
We could have done permutation of 26 things arranged in 3 spots. Because you're picking from 26 things arranged in 3 spots. If we use our formula, on top it is the bigger number, 26 factorial. On bottom it is 26 minus 3 factorial. Now, that cleans up to be what? 26 factorial out of, or over 23 factorial? Now, I don't write it all out either, okay? But here's what I do, is I think, okay, 26 times 25 times 24 times 23 times 22, ... Over, what's 23 factorial? 23, 22, ... Do you see what I'm saying here? Because what's going to cancel? 23, 22, and ... The rest. I'm not crazy. I'm not writing them all out, okay? Someone got an answer on this one at some point, yes? 15,600 options. Okay? That is permutations. Order matters. Tomorrow we will venture into combinations where order does not matter. Okay? Make sure you get 12